Up until now, we have looked at series resistors separately from parallel resistors, and now we're going to transition into applying what we've learned to both series and parallel combination circuits. So try to keep some things in mind. First of all, that the current is the same throughout series components in your circuit, and the voltage is the same across parallel elements. So let's look at just combining resistance first, okay? Because the first step in analyzing series parallel DC circuits is typically going to be in combining your resistors. So let's look at the following resistor networks and try to determine what our total resistance would be looking in at the terminals we're given. What do I mean by that? I mean that when we're asked for RT looking from the left-hand side to the right-hand side, imagine putting an ohmmeter, hooking up an ohmmeter to your circuit here and here. And then imagine the ohmmeter is actually supplying a little bit of current to your circuit. And I'll show you what that looks like. So let's assume that we're putting a little bit of current into the circuit and try to trace through the path of that current to decide which resistors are impacting the total resistance of the circuit. So once we get to this point after that 4 ohm resistor, what do you think happens? Well, no current is going to go through here, right? Because this is an open circuit right here. And we know that there's no current through an open circuit. So no current would go this way. All of the current would instead go this way and then return back to that ohmmeter. So the path that we have for our current is right here. And what does that look like to you? To me, that says that we have 3 series resistors, because the same current through the 4 ohm continues through the 10, continues through the 4. So in this case, I would say that RT is equal to 4 ohms plus 10 ohms plus 4 ohms, or 18 ohms total. Let's look at another example. I'll leave that one there for a minute. Okay, here we've got 3 10 ohm resistors, and again, I just want you to imagine, I think I'll draw it in a different color this time. Imagine our ohmmeter here, connected here and here, because that's where we want to know what our RT is, and imagine it's putting a little bit of current through the circuit. Obviously, that current continues through the 10 ohm resistor. And then what happens? Well, we actually do have 2 paths for current. So some of our current will go this way. Some of our current will go this way. I'm drawing it in a different color to show you that those are different currents. Okay. And then they'll come back together on the other side. So what do we have here? Well, we have current through the 10 ohm resistor, and that's not the same current that's through the other 2 10 ohm resistors, so they're not in series. So what we do have, if we notice, connected right here, our 10 ohm resistor is connected to both the other 10 ohm resistors on one side, and then on the other side, notice the 2 10s down here are connected. So that means that these 2 10 ohm resistors are in parallel. And I'm going to draw that like this. I'm going to say 10 in parallel with 10. So my first step would be to combine my 2 10s here. So 10 in parallel with 10. To calculate that, 1 over 10 plus 1 over 10, and then I invert that again, which should be 5 ohms. And this is the original 10 ohms I had right here. Okay, so that's the first step. Now what we see is that the 10 and the 5 are in series. So RT would just be 10 plus 5 ohms, or 15 ohms. All right, let's try another one. And again, I'm going to leave that up there in case you're still taking notes on that. You can always pause the video. That's one thing I like about having the videos, is that you can pause this and then you can rewatch it if you need to. It's a little hard to do when you sit through a lecture, right? So that's actually, I think, one of the benefits of what we're doing right now, is that if you need a little more time with the material, you can have it. And if you need to speed things up because you really do understand what's going on, and I don't even really have to explain it, you can kind of skip ahead a little bit too, or speed up the videos if you want to do that. Okay, so again, I'm applying my ohm meter here on the left, and then I'm going to trace through the path of current. So when I put a little bit of current here, I notice that there's a little junction here. And the question I want to ask is, will I have any current splitting at that point? Well, it depends on whether that current can get back or not. Okay, so let's just imagine some of the current goes this way. What happens to it at this point? Well, it's not going to go to the right because that's open over there, but it can go back to the left. And it can kind of meet up right here. So yeah, we could have current right there. And then let's say some of our current goes this way. That's going to intersect back at that point and come back together. Okay, again, I'm ignoring this portion of the circuit over here and here because that's open. And that's why I ignore that over there. But it looks like I do have a couple paths for current. So now the next step is to figure out how those resistors are related. Are any of them in series? Are any of them in parallel? So what I like to do is start just kind of making some connections in. I like using the colors because that tends to help see the connections a little better. So right here we've got these 4 ohms connected. On the other side, this is connected to here. And then on the other side, we're connected to here. And then here. All right, so what does that tell us? Well, right here, notice that our 4 ohm and our other 4 ohm have that one connection between them. There's no other path for current to take between them, and they're not in parallel. So actually those two 4 ohm resistors are in series. Okay, so I would say, and I'm going to call this R prime, or actually let's call it RA. I think I like RA better. RA would be 4 plus 4, or 8 ohms. So what I would do is I would remove these 2 resistors. Okay, so basically take that path right there, remove the 2 resistors, and put back the 8 ohm resistor. So let me just draw, first of all, the 4 and the 10 that we're keeping, that didn't change. And then let's figure out where to put that 8 ohms back. Well, if you notice, one side of the 8 ohm resistance is connected to here. The other side is connected to the other side of the 4 ohm resistor. So that 8 ohms is right here. Okay. And we're still measuring from here to here. All right, next, notice that this 8 ohms is in parallel with my 4 because they're connected in 2 points. So my next calculation, which I'm going to call RB, would be 8 ohms in parallel with the 4 ohms. Okay, when we do that, 8 and 4 gives us 2.67 ohms of resistance. And I'm going to redraw my circuit again. Now, I suggest you really start practicing redrawing the circuit, okay? It's really useful in series parallel combination circuits. So where do I put this back? Well, this was one end of my parallel resistor network, and that was the other end. So this resistor right here is now 2.67 ohms. And now my total resistance is just the sum of my two series resistors, now that they're in series. And there's my RT. Okay, now let's do one more, and then we'll move into creating an actual circuit. Okay, again, start with your ohm meter out here. You don't have to draw the ohm meter. I'm just trying to do that to illustrate what we're looking at. As a matter of fact, I'm just going to leave it off this time. But we're looking for the total resistance looking in from the terminals on the left-hand side. And that's important. It really does change the value of the resistance if you change where you're looking from in the circuit. So we're looking from over here. So think about the path that current would take from that meter. And at this point, it looks like we could have a split of that current, but keep in mind that this branch right here has 0 ohms of resistance, whereas the other branch in parallel with it has 8 ohms of resistance. So our current's never going to go this way, okay? We're never going to have a current in that direction. So all of the current will continue this way and back to where you started. So for this particular circuit, RT is simply that 10 ohm resistor, and we would never have any current get to the 4 and the 4. So that would not be part of our total resistance.